Hello, this is Kristen,
And Scott.
and we'll be doing our lesson 8 group problems.
Mhm. So the first question that we had was about some alleles that have had an inversion on them, and it asks us some questions. It says, what is the allele and centromere composition of the four products of meiosis if there's a crossover between S and T? And it gives you the two different chromosomes, the normal chromosome and the inverted chromosome. And so what I drew here on the board, and it's kind of rough, but it shows you a little bit of what's happening to these chromosomes during the inversion. And well, they are going through meiosis. So you have the different alleles here represented by letters, and here where the centromeres are, and this is where the crossover happens. And so the four different kinds of alleles, first you're going to, or the four different kinds of products of meiosis. The first two are going to be just the parents, so LMNOPQRSTUVWX, and then the other one, which is LMNOPQ, and then just following the strand VUTSR, and then WX last. And then the other two, the reason why there's this fold here is so the two can have adjacent alleles touch each other. So the R and the R with each other, the S and the S, the T and the T, the U and the U, V, V. So this one has a loop so that they can be able to be together. And so the other two, there's LMNOPQRS, and then it switches over TUV, PQO, and ML. So this one will have two centromeres in it. And then the other one is actually going to start from the end and go XWVUT, then switch over to this one, RSWX. And so those are the four different combinations that can be produced by this kind of crossover between the two different chromosomes.
Perfect. So for question number 2, it's just fill in the blank. So I'll just read the answers. So for part A, it says non-disjunction in meiosis produces 50% aneuploid gametes, whereas non-disjunction in mitosis can produce mosaic phenotypes. And for part B, meiosis in an individual who has suffered a paracentric inversion produces a dicentric chromosome and acentric chromosome. And for part C, Turner syndrome is an example of human disease caused by monosomy, while familial Down syndrome is an example of disease caused by Robertsonian translocation. And for part D, the human liver cells can be 4N, 8N, or 16N. Part E, a terminal deletion in chromosome 5 causes Cry-Du-Chat. I don't know if I pronounced that correct. And then inversion on the X chromosome causes hemophilia A. And then for F, a duplication in a change of chromosome structure can be potentially beneficial. And then for part G, a translocation is formed. When a translocation cross is formed, the alternate segregation pattern can produce viable gametes and offspring.
Cool. So for part 3, it's asking about, well, for the first part of part 3, 3A, it's asking about some different syndromes and different diseases that people have that are caused by chromosome-related issues. And it asks about the number of chromosomes that you would find inside of individuals with these diseases. So the first is Turner syndrome, and Turner syndrome is it's where you just have an X chromosome. There's no second sex chromosome, it's just an X. And so with Turner syndrome, you'll just have 45 instead of the typical 46. For Jacob syndrome, you'll have That's XYY, right? You'll have 2 X chromosomes and a Y chromosome, and so that'll give you 47. Crew to chat. So in crew to chat, you will have a terminal deletion, which means that there will be part of a chromosome cut off or deleted from part of a chromosome that won't have a centromere on it. And so because that has been deleted off of it, the centromere, it'll end up getting dissolved and lost. And so those with crew to chat will actually have 45 chromosomes. And then familial Down syndrome, you will end up having 46 chromosomes in the end. You'll have a you'll have a, I forget what it's called, the Robertson's translocation. Basically, you'll lose one chromosome and gain another like mutated chromosome, and so in the end you'll have 46 chromosomes. And then in type A hemophilia, you'll have 46. There will be no change in your chromosome count. Part B, they give us some terms and ask us which one is not associated with Charcot-Marie tooth disease type 1A. The answer is all but duplication and diploid are not associated. Everything else is not associated with diploid and duplication are. And then they give us some more following terms and ask us about which ones are associated with Klinefelters. And trisomy, non-disjunction, and aneuploidy are associated with Klinefelter syndrome. And then the last part of part 3 is it asks us about some terms that are associated with type A hemophilia. And out of all those terms, actually none of them are associated with type A hemophilia.
All right, so for question number 4, for the first part, it asks to diagram the synapses of these chromosomes. So here it is, here, you can see that. And then for part B, it says to identify the allele composition of alternate segregation. So we're going to get this allele, this, and paired with this, and then this one here, paired with that one. And then for part C, it asks to identify the allele compositions in adjacent 1 segregation. And so the 2 alleles here are going to be paired with each other. And then the 2 alleles here are going to be paired with each other. And then for part D, it asks the adjacent 2 segregation. And then these 2 alleles are going to be together for this segregation, and these 2 alleles are going to be together for that segregation.
Cool. So now on to part 5. And so it gives us a cat, and since its chromosome count is 38 chromosomes in total. And then it asks how many total chromosomes would be found in different kinds of cats. So the first is a triploid cat. So since the diploid number is 38, the triploid number, you would either divide it by 2 to get n1, or 1n, and then times it by 3 to get 3n, or triploid, or you could just times 38 by 1.5, and you'd end up with 57 chromosomes, either way. Part B says cat that is monosomic for chromosome 12, and that would mean it's n minus 1, so they're missing 1 chromosome, and that is 37. And then a cat that has suffered a terminal deletion on chromosome 7, and since it's a terminal deletion, it will end up rejecting one of the chromosomes, and you'll have 37 chromosomes instead of 38. And then a cat that suffered Robertsonian translocation between chromosome 17 and 18. So this is actually a trick question. You can't have Robertsonian translocation between those two chromosomes. It has to be, I think, 13, 14, 15, 21, and yep, exactly what she said. And so you can't have a Robertsonian translocation between those two. And then a cat that has suffered a reciprocal translocation between chromosomes 6 and 9. And so if it's a reciprocal translocation, the actual number of chromosomes won't be affected by that. So you'll still have 38 chromosomes.
All right, thanks for watching, guys.
Mm-hmm.